Hey guys, how are you? Welcome back. Welcome back. It's a new chapter. So today is actually going to be exciting because today we get to practice a lot of the things we've been talking about. And more specifically, we're going to be talking a little bit about coding, free and coding-based approaches to machine learning to ML. And this really stems from the background to this is actually interesting. Because whenever you talk about, ML in civil or, and not just in civil, also in other areas as well, there is always going to be a talk, well, we don't really teach coding or we don't know coding as well or programming as well. Or we have a lot of issues when it comes to coding. We don't tend to teach it as much, or maybe you have like a course here or a course there. I think a lot of schools now they teach some form of programming and freshman, sophomore years, and then you take other courses, and there isn't, really much ML going on there. And because this was a big problem, the coding was a big problem. I just felt, I mean, as long, and along with many other people as well, that one of the biggest issues when it comes to ML is the need for coding. And nowadays, we're very fortunate because we could actually use machine learning without having to rely much on coding, which is great. But the option is always there. You could always, go back and learn coding. Coding is not really that hard to learn. I think it's a cool thing to learn. It's like a new language, and I think it's interesting. Personally, I do think so. Um, but I always think of coding just like FE. We don't really have to have all engineers know how to use FE well, but we need them to know the principles of FE, I guess. Same thing with coding. If you're like, especially in my class. The emphasis, and if you go back to the first recording, we're really trying to learn the principles and fundamentals. And once we do that, then the application component, the applying of those principles, which is in this case coding/programming, becomes, I think, a secondary item. I don't think this should be the focus of a course on ML, unless the course is actually teaching students how to become coders, how to work with coding. But overall, I think the idea should be, well, here's the principles, here's what ML is, this is how you take a model, break it, build it, learn it, explain it. And once you know all of that, then it becomes an easy approach to go and try it and start the program. And the code for this chapter is actually something very like brings a lot of memories. If you happen to be like a Matrix fan, there's that famous scene when Morpheus says, here's the blue pill, and then you're gonna go back to the red pill, and you get to choose, what which one to go for. So to me, this sounds like, you have a coding-free approach and you have the coding-based approach, and you get to go through the rabbit hole of ML. So we're somewhere here, somewhere here. We have data, we build a model, we know how to evaluate the model, and we're trying to build this model so we can uh, deploy it. Actually, you build the model, you validate, evaluate, and then you deploy. So you're somewhere between these two portions here. So the slides for this chapter, as you can see, or as you can see on the left side here, they're mainly tutorials, how to use this platform, how to use that platform. So there is a lot of tutorials going on there. And I would rather not to go through the slides because I would rather do the tutorials so we can do them together. But this is why, for instance, we're gonna not be spending a lot of time on the slides because we're gonna do the tutorials, on hand. I don't think I'll be doing all tutorials. I think we're gonna be doing a few of them because it becomes repetitive after some time. I don't want this to be like a very hard exercise where it's repetitive. But to start with, so if for those interested in coding, you can always try Python or R. So I have these, and you can easily download them and use them. There's a very cool option in Google. Like if you have a Google account, you can have like your own collab uh, Python dash thing that you can try. Let me show you how this one looks like. Mm, Up here. So once you log into your account, you can easily go to Collab, or basically if you type in Collab, Google, it should pop up right there. And this is where like a playback would look like. Let's say this is test. So you could favorite, so you can always come back to it. You can also not favorite. You can have a lot of things that go on here. Nowadays, you can actually start coding yourself, or you can generate something with AI. For instance, you can say something, well, Brent, hello, friend. There we go. Here it is. So you have the prompt. This is the actual prompt, and then this is the Python prompt. And if you play this, it should show up and say, well, here's hello, hello, friend. You can also do, and do something else. You can easily create, I don't know, let's say something like this. Well, multiply 5 by 10. Let's see. I haven't tried this before. There you go. There you go, 50. Now this is us writing what we want to do, and platform does the prompts for us. You could also as easily as easy as this. You can actually write the comment yourself, or like the script yourself, and you can say, well, here's the Python comment, and instead of this, let's say hello and now. There you go. Hello. Hello. So this is how you could use Python very, very easily. You don't even have to have the thing on your device anymore. You can just try it on the platform on Collab. So you can easily find Collab here, collab.research.google.com. There's plenty of things that you could do. Now let's go back to the slides a little bit. You could do the same thing with R, and download R from VoiceIt. And the same process goes on. Same process. I don't think I have R on my device here. So to start with, I'm gonna show you a few platforms. We're gonna try a few of these. And once you really try one, it becomes very, very similar for the rest, because most of these are designed with very high intuition. So it should be very intuitive to navigate. And you'll see how like soon. The platforms I have in the book are really the ones that I reached out to and I asked for permission, but I know there is like many, many other ones that you could try. And the cool thing about these platforms, some of them are platforms you could access online, some you could download. We can try both of these. But almost all of them, they have the student account thing. So you can just sign up on the student account and you should be good. For instance, bigml.com. You could sign up for it, and if you sign up, for instance, I believe if you go here, you get like 14 days of free trial, and you can have many, many models there. So this is ML, big ML. I like I use a lot of Data Robot, because when I started the whole thing, it was with Data Robot. So Data Robot is, I think it's a firm in Boston. They're big now, and you can see there is a lot of other companies that work for them. So once you create an account and once you log in, you're gonna see something like this. So this is basically the very first page that you'll see. All what you really need to do is to drag, let's say, a data set. Let's say in this case, I'm gonna be dragging this data set here. Am I sharing this screen right now? Perfect. It's gonna take a minute to upload. You're gonna have a number of workers here. I think Data Robot, if I'm not mistaken, yes, Data Robot, when I started with them, there's like an academy for faculty members. So if you sign up for them, I'm hoping it's still there. You get to have like I think 3 days or 2 days of practice. So you get to go over the whole platform, how to use different things, certain things. It's very interesting. And you get like a very big package of data sets and stuff. So the first thing is basically trying to upload the data. And while it's uploading the data, if you look at the right-hand side, basically Data Robot tells you, okay, well, the next action would be select target. So if you go scroll down, You'll see we have diameter, tube thickness, effective length. All these are the features. You can see that they're numeric, how many unique values you have, how many missings, mean, standard deviation. You can actually, if you click on this, you can transform them. You'll also see something like this. For instance, here I have failure mode as a categorical uh, feature, column type as another one. So what you could do is you can say, well, you know what, I'm only going to be dealing with these because my target is going to be the axial capacity. So you can make a menu and you can have it like a sub feature. You can choose those or not. So what we're going to be doing now, let's see. I would like to, let me use everything. I would like an exit capacity to be the target. And let's keep it, let's keep it mixed. Yeah, that'll be interesting to see. So we're gonna keep all features. I'm gonna only keep the active capacity as a target. And here we can explore the data. Oops, it's loading. So once the loading is over, you can see different histograms, different scatter plots. You also have a data quality assessment. It would say, you know, this feature might have too many missings, or this feature is low on something. And if you go all the way up, you can see that now the platform knows that this is going to be a regression problem because the axial capacity is a numeric. If you choose no target, then it's going to be an unsupervised learning. It could be anomalies or clusters. If you go for, let's say, failure mode, this would be a classification problem because it could buckle or it could crash, right? So let's keep this simple. Let's go to axial capacity. Let's keep everything as is. In a perfect, I think when I teach this, I usually just keep numerical values and I remove these. I don't think I'm gonna be doing this now because I don't want to have multiple examples. Um, you know what? Let's try. Let's see. Oops, so here we go. Well, in this case, no. Show me the whole features. So this is how you can navigate between different features. Now this one's supposed to be categorical, but I mistakenly labeled it as numerical. But it doesn't really matter that much because we can always go back and I don't want this and I don't want this, all this uh, for numerical analysis. Now we only have numerical values here. If you also want to see this show advanced options, it would ask, do you want to like do cross-validation, train and validation holdout? Let's keep this as 5 or 10. You can see it changes everything, holdout percentage as well. Additional is usually where things become a little bit more informative, and this is where you would suggest like a performance matrix. I'm going to go with R square as the performance matrix. So basically, each model will be created and will try to optimize its performance based on R square. You could choose other ones. You can have gamma deviance, RMSE, Jenny, you know, all the other ones. You could option to search for interaction. You could option to use SHAB, which we will discover in the next chapter, which is try to explain a way to explain models. You could ask data robot to prepare a model for deployment, so it would choose the best performing model as it for deployment. You could also say, well, you know what, create blunders. What creating blunders mean I'm going to be using the best of the best. So let's say the top 3, I'm going to create a new model. We call this ensemble. We'll learn about this in chapter 9, a little bit further. And there is a lot of, you could have different and different offsets too, but this could be for different analysis. By default, you could have autopilot, quick, manual, and comprehensive. So comprehensive runs everything we have, all the models. Manual, you get to choose your models. Quick is where you create quick models. Autopilot is where data robot picks the best predictive model. What I want to try, I'm going to go for manual because I want to pick and choose a few models. Once I hit start, oops, then this one, oh yeah, oh my bad. We have to remove that blundering thing. Let's Well, we don't really have it. Let's see, did I miss something? Let's go back. Oh, okay, no. So it's now it's labeled. So we don't really need this. Hmm, Subject cannot be used if include only models. Yeah, I didn't include it. Did I? Am I including this? Let's simplify. Let's try to refresh this. So yeah, there we go. That's all what we need is a little refresh. So now if you can see here on the right hand side, you can see we're setting the target value. We're going to be creating cross validation, holder partitions, analyzing some features, and all of those things will be done. So we don't have to bother with any of those. Here we have informative features, raw features, our own list of analyses. I mean, list of features too. Perfect. So now we're generating blueprints, and if you go to models now, you can see that Data Robot runs a number of models on the right side. So we have elastic nets. Let's skip some of these. Generalized models, LGBMs. One of them is enough. Random forest. Let's not go with roll fit. XGBoost. So here is where things are being ran, and you can see here that we have already some validation values. You can change the metric. It's the R square. So for validation, it's almost 99%. Wow. 96 for GAMs with interactions. Random forest 94. XGBoost is 98. Then trans cross validation and holdout are usually left over until we're done with the analysis. But from here, you can learn a lot of things. So for instance, in this case, what we could do is I'm really trying to push this. Let's just delete these two. You can delete them. Perfect. So this is blueprint 64, model 7, model 11, blueprint 68, and this is with mono options. So we could, so LGBM is done. It's going to be analysis. Let's see XGBoost. Oh, mm, let's go back to data for a little bit and try to see. Yeah, if you click on the data now, you can see the histograms for all the data. You can also do some feature engineering. You can say, well, you know what, I'm gonna try to make this square or divide this or change the variable type. Somebody would say, well, can I divide this by that? Yes, you could. You could divide multiple ones and you can have come up with a new feature. Go back to models. Okay, so we're almost done. As you can see, XGBoost is 98, 96, LGBM is 99, 93. So basically, based on cross-validation, XGBoost is the best performing model. Based on validation, LGBM is. Now, for the best model, Data Robot will try. You can understand. This is how you see the blueprint for the model. If you go to understand, data robot tries to compute feature impact, feature importance, as well as feature effects, which is something similar to PDBs. It can also predict explanations. We might have some values. Here we go. So for light GBM, you can see the importance is diameter, the tube thickness, and so on and so forth. Feature effects. If we go, we're gonna have to compute those. So probably it has done it for. No, we have to do that too. Okay, so feature impact here for XGBM. If you think about this, I think the whole process took like a few minutes from start to end. Yep. So we have those now. Feature effects. Computing still. Let's see, maybe LGBMs. It's done. There we go. So in this case, you can see the effect of the diameter, thickness, compressive strength, effective length. You can try this for the training data like that. So this is the one recommended for deployment. For validation, for training, you can see the effect. You can also plot lifted in actuals, partial dependence, you can remove it. All these very, very fancy things. And here, this is for the whole thing. All of this done for the informative feature. So for everything we have, you can also rerun the analysis, let's say for n numerical or for the new feature list and see the good stuff from there. This little store is, so this is the best model we have, and this model is now frozen. So all its setting has been frozen. If you, for instance, want to push XGBoost a little bit, what you could do is you could go to evaluate. You can see a little bit more of things that you can evaluate the model. For instance, you can see residuals, you can see distributions, you can highlight the ones with more than standard deviation or 2 standard deviations. You could do this for validation, cross-validation, all data, a data slice. But this is one of the coolest thing here. Oops. I think I missed here. Very advanced tool here. This is where you get to see all the options for XGBoost, and you could basically try to change them. And if you want to change something, data robot would say, well, we've used this, and the best of search is this, but you have acceptable levels from this much to this much. So you could try those. You can also see the documentation for each particular parameter. It's fascinating that you can automate the whole process. You could change this a little bit. You could now predict. Let's say you have a new data. Now you have the model. Model seems to work nicely. We can now plug in a new data and predict this data set. So now this is how your model would work, because now it's trained. It used to be an XGBoost algorithm. It's trained, been validated, seems to work well. You can add in your data here, and you can now predict new stuff. You could also build an app, that you can see. Let's see. Let's call this game test. I want to see if I can do this. Nobody can say, okay, so we're gonna have to have a server. Unfortunately, I don't have one now. But you can easily build this, you could deploy it, and you can try different things. There are a few insights here. For instance, you could compare, you can see the feature importance for the different models, how do they change? You can see learning curves. For instance, this was for XGBoost and gradient. If you always look at the y-axis, because the difference is very, very small. This is 98.9, this is 99.5, so difference small. You could compare speed and accuracy, could have other comparisons between the models, for instance, in this case. You could see dual fit, you could see fit. You could try different pins. So you can see a little bit. On some data points, one overcomes from the other one. Now, let's go back to models, repository. So this is where you can pick and choose the model. And I want to choose a specific model. I want to choose, yes, Eureka, because we talk about symbolic regression in chapter 9, and I know we're going to be mentioning those. So let me choose maybe one. Let's go with a regressor. No, that's going to take a little bit of time. Maybe with this 250. There is a big repository of different models. You can see here a lot of models that you could use. Oh, let's run this. Let's go back to the leaderboard. And now you would see that Eurekas uh, are being run here. Well, let's cancel this one. I don't really need this one. I just want to give the Eurekas. Okay, so let's remove this one here since we already have an LG boost. I mean LGBM. Model processing. No, processing. Yeah. Oh, well, I can delete because this one is built on it, so you have to keep this one. What you could do is these two models are really good. You can actually go to blending and you can make an average model, right? An average ensemble. So basically, you're taking the predictions from both of them and you're averaging them so you can have a new prediction that you could be a little bit more accurate than the other ones. So here we see that Eureka is 91. Let's run this. In this case, it's -10. So this is a very poor model. It's basically because we don't really have enough generations for it to run. So let's keep this. Let's not run it. Let's run the other one. And Eurekas are interesting because they give you as let's see. So you have similar behavior. Um, you can compute those. We could predict. Where are we? Oh, so it's 94 now, so it's finished. The validation. Model info, you can see model size, train samples. You go to Eureka models. This is basically an equation now. So the model works as an equation, and now you can just take this equation, plug it in your Excel, and you don't have to run ML anymore because now you have a model that works actually very well, and you can transform this model from an ML model into a mathematical equation. This is what we call symbolic regression. And you can also, for instance, this equation is for this last model here. If you look at the first model, you can see that the error was substantial. Oh, wow. This is the equation for it. Then we had improvement. We're improving, we're improving, and eventually we're here. So this is going to be the model that we have, and this is the model that gave us these accuracies. If this should remind you of something we've done before, except it's not deformation. Okay, perfect. This is actually very good because for a lot of our problems, uh, we do have a lot of we like to have equations. You can have a log of whatever is going on. Again, you could add some data to try again. You can do feature impact, feature effect. Of course, and this is just like the glimpse of data, but there's hundreds of more options you could do. I wish we could spend more time on it, but as you can see here, we do have a lot of things to go through in this report. So let's just see this. Now you can see the features that positively influence the model and the ones that negatively influence the model. This is something new. Model history applications. Yeah, let's not go there. Let's not go there. Let's see if we can see any differences here. Not really comparison. No. After we can also change this into, let's say, Eureka. And you can see the behavior across different bands of data. Not bad. Now, the second thing that we could also see, Data IQ, it's another platform that you could use, very similar to Data Robot. We're not going to go through this one now, but this is another option that you could use. I have it in the slides. Exploratory is great. And this one is a software that you can download. And I think we've seen this when we did the statistics chapter 2 or chapter 3. Let's see what we have here. So you can easily download this. You can go back to our chapter 3 examples. We know how to do all of these things. This is done automatically. Now we know how to plot from the chart options, as we've done last time. The new thing is going to be if you go to analytics, we've done correlation, but in this case, somebody would say, well, you know what? I want to run a decision tree model, or a random forest model, or an XGBoost model. Target variable is going to be, let's remove this one here first. Let's keep this pure numerical. I'm going to keep the axial capacity as the output or the target. I have all the predictors: diameter, thickness, length, yield, compressive strength. It's very quick. So these are the PDPs. This is the summary for the model. As you can see, R squared is 99. You can tell that there isn't like testing and validation. So what you can go is you can come here. Let's see, we have it down there. You could choose the error metric from here. Let's keep it as is. And if we go down test mode, you can say true. By default is 70-30. So let's keep this. And now it's gonna run again. And for training is 99. For testing is almost 91. That's great. Again, for predictions, you can see the different predictions. You can see there is a lot of influence from the diameter. Big influence there. Importance of features, of course, diameter, massive. This is the learning curve with how many iterations we have. We have also actual versus predictions. So you can see we kind of have a very good yeah, if you look here, there is a lot of those points above the 45-degree line. What about this? Yeah, all of it. And of course, we have all the data here, even the predicted values. And it would tell you, did the model use this data point in testing or no? You can have a lot of visualization. What you could also use is somebody would say, can I use decision tree? Let me just go back here and remember those numbers, 99, 90. Okay, so that's for XGBoost, 99, 90. If we change this to the decision tree, you can see the tree. And this is 88, 80, 89, 82, so it's a little bit less. If we try random forest, then we should have improvement here with random forest. 93.75. So it improved on the training, but not so much on testing. That'd be interesting to investigate. We could try other models, linear regression. So you could do also time series analysis. If you have anything like with time or air quality, water quality, you can go there. You can do some statistical tests, ANOVA t-test, normality test, all those things. Survival analysis too, you could try. Now let's do some clustering. Let's keep it, let's make it a little bit complex. Let's add this one too. So this is k-means. Oh, so this is what we have. So by default, we have 3 clusters. Let's see the summary first. So number of rows you can see in each cluster. This is the pie plot. So basically, this one tells us this is for these ones in orange are highly influenced by the yield strength and effective length. The blue cluster is influenced by yield strength, tube diameter, and axial capacity. The green cluster seems to be involved with compressive strength and axial capacity. Now, if we remove the axial capacity, rerun this, there you go. Let's see, it shifted a little bit. You can also try, so by default, we always have 3 clusters. If you come here and you try find the optimal number of clusters, you run this and you can see the elbow is somewhere here. And somebody could also say here 5 clusters, 5 or 7. So we go back up and we say, you know what, let's see 5. And let's go, oops, my bad. There we go. So now we have 5 clusters. You can see all of them right there. So you can see the blue ones are all a bit away from the center. We also have box plots. You can see them for the different clusters here. For instance, in cluster 1, you can see a lot of influence uh, from the diameter. You could also look at the diameter or the polar plot. So these are the clusters here. You can see the blue cluster, the first one is influenced by, seems to be the geometric features, tube thickness, diameter, effective length. The green cluster, a lot of compressive strength influence there. We also have them in lines. These might be a little bit hard to visualize. And of course, we have the data and we have the cluster limits. So you can easily transfer, publish this or send this into Excel or save it. Oops, other than clustering, what else do we have? We've done correlation, PCA, factor analysis, all these things you can try. What I like about exploratory is you can actually save this. Like once you save this, you'll have a link to the project, and that link you could share with your friends, with your colleagues, so they can continue. I find this very interesting to work for, like in my class, for group projects or homework, because students will be working together. Somebody would do correlation, the other one would do clustering, the third one would do maybe like some machine learning analysis, and they all can work remotely together at the same time. Anything else that we would like? One thing about about exploratory is this is R based, by the way, which means you can easily write your own R script too. So you can, play with R. And they have a very good YouTube channel, so you can go there and like learn a lot about different types of analyses and different data sets and all those interesting stuff. Let's see, linear regression. Can we have something with linear regression? Comparison with model, maybe. Oh, linear regression is 87%. Oh, that's not bad. These are the coefficients. So this is the coefficient, this is the intercept coefficient for each feature. So you can basically say this multiplied by this plus this multiplied by this plus this multiplied by this, and here's your equation. It's almost as good as symbolic regression, because if I remember, it was 90 something. You get to see this residual distributions, residual predictions, actual versus predictions. Yep, this is a very good example, actually. I'm glad we did this. Let's think about this. So we're supposed to figure out from linear regression an equation that predicts the axial capacity. Now the axial capacity is always positive. In this case, we have negative capacity. Negative x's. How can you have a negative capacity? And if you look at the model performance, it's actually very good. And this one tells you because we have so much data. All of these are actually good, so they're gonna overcome the negatives we see, which is makes you think. So actual values, as you can see, the actual values are positive because they are positive. This is from the experiments, but the predicted values tend to be negative. So it's a model issue. An easy fix would be maybe to add like an absolute to these coefficients. To the equation itself, and we should be we should be good to go, probably. Can have significance for coefficients, importance, diameter, EDPs. Because everything is linear, you can see a lot of emphasis on the straight lines. Okay. Anything else in mind for exploratory? Forest, generalized models, we have those. I think we're good. I think we're good. Let's go back to our browser. So I'm sure you're all familiar with ChatGPT now. Uh, you can easily use it to try to see if we can. So in this case here, let's say something like ChatGPT is actually can be helpful. Just as you can see here, we can have to be careful. ChatGPT can make mistakes, consider checking important information. So it's always good to go back and check. Let's see. Oh, how can I assess it today? Well, I'm recording a lecture. You can see my spelling is not, it's not the best. For civil and environmental engineering students. Do you have any thoughts that you would like to share with us? Let's see. There you go. So this is basically a list of things I'm supposed to do. Outline your lectures. We do have a good outline. Visual aids. We try our best. Engage with examples. I'm hoping this chapter does it. Explain concepts clearly. Hopefully we are. Analogies are great. Demonstrate problem solving. So you can see there's a lot of good thing that, could come back with the general stuff. It's actually very helpful. It's actually very helpful. Okay. Let's see. Let's make this a little bit interesting. What's the answer to 9.9 times 1.1? There you go. Okay, not that bad. That's good. Of course, ChatGPT, as you know, it's very easy to use. A lot of people don't know this, but there's also a board version, like a Google version. If you have a Google account, you can easily uh use board. Let's see if you can. Yeah, I've been trying to use it today, but unfortunately, I keep getting this. Something is wrong. I'm not really sure why. Let's see, try. Yeah, it just could be a glitch. I don't have the best. See? Hmm, well, oh, I'm missing like GPT-2. You could now input like images and text, and can help you with those. They have also DALL-E. You can create images. The free option is always character AI. Oh, there you go. I should have like copied that statement they had in ChatGPT first. Well, let's see. What is, this maybe is interesting. About yourself. There you go. That's a very nice icebreaker. Okay, that's good. So now you've seen all those different softwares and stuff. So this was exactly what I wanted to go through for this. You can see data robot here, data queue here too. It's a similar platform too. There is a lot of similarity too between these platforms, as you can see. Big data, big models. You can see here random forest, gradient boosting, KNNs, lasers, neural networks. You have a leaderboard Exploratory. We've done this many, many times by now. Clarify is also great. Clarify is great for computer vision actually. And even data robot does well for computer vision. You can if you have a database of images, I do have one. It's actually with the and you can also have that one too online. You can just upload the images and it does the analysis for you as simple as those. Like for instance here, I have all those images of cracked sections, and we're trying to create a model that can show us where the cracking is. For instance, this is a crack. There is no crack here. If I zoom in, you probably can see it better. Yeah, zero crack, crack one, or the first crack, second crack. There is no crack in here. It's very fascinating. It works a lot with. You also have a confusion matrix, and you can investigate binary matrix. And here is how you define this is a major crack because you can see the reinforcement and stuff. These are some of the tools you could use. We've seen this. We've seen character AI board we couldn't unfortunately access, but all these are also freely available online. Goodbye. Now, if you go back to our PDF, well, as you know, this chapter might be the largest chapter in the because it has all those screenshots from the different platforms. Yeah, this. I was speaking about this for a while. If there is a problem, try to remove it. You're always going to have an issue with coding. But let's just not code for a little bit and see if we can, get to learn and use AI or ML properly and stuff. Of course, there's also Kaggle to try, uh, OpenML, Databricks. There's many, many platforms you could use. Um, this is big ML. What I like about big ML, this is something that you don't, well, now other platforms have it too. A few months ago, they didn't. Whenever you have a model that works, you can actually uh, download the model. So you can have all the Python script written, and you can just copy it and paste it. This is all from BigML. So whenever you have a model that works, you can see feature importance, different trees. You can easily copy just say, export Python or export R, and you have the whole code, and that's it, you're done. You basically have very, very little need to code. So for most problems that you're going to go over or you're going to face, there is really very small need to code something by hand. There's a lot of all these platforms does the coding for us. And this is why, I'm not really pushing for coding free stuff. I'm just saying it's a little bit easier to use, especially for introductory course or for somebody who's new into ML. Because if we keep pushing the coding stuff, you're gonna have to think about, well, we have to have a new course. Well, I don't have enough time in 16 weeks to teach coding and all those fancy stuff. So the idea is, simplify, find a way around it. Well, let's just present ML, give an option to try it. And for those like unique problems or for those interested students or like, researchers slash engineers, you can do the coding. It's not that hard, really. This is the way that you can add pictures or images into data robot, as you can see. Same data set for complete cracking. There we go. So it actually identifies and would say, well, all these colors are cracks. You can see the reinforcement. So these are the cracks. It kind of explains its own predictions. Data IQ, seen that, clarify. Yeah, we just went through this. And yeah, so this might be something that you guys would be interested in. I also have the same examples. In 6.2, we have the coding base. So we actually have the Python codes and the R codes for the problems. So you can copy them, try them on Colab. And you have the data sets too, so you can try those, maybe make the figures nicer, a little bit different colors. Stay away from the default ones, examine matrices, confusion matrices, AUCs, all those fancy stuff. I have them for clustering, I have them for binary classification, I have them for regression problems too. Try those, please. When I teach this chapter, so let me just finish up this chapter. So that's it. We're done here. We have a few questions. Most of these, repeat the example or like do a problem, homework problem. If you go back to my slides, if you go back all the way up, yeah. So what I normally do in my class, whenever we hit this chapter, I do have two lectures. So one lecture just on Python. I usually have one of my students, they lead the coding, so we install Python and we run a few scripts, we run a few models, and the other students, they just, follow step by step. So you spend one lecture on Python, then the next lecture is on R. So now by the second lecture, they kind of have a feeling of what coding is, how does it work, the amount of work. And then in the third lecture, you go over one or two platforms, and the fourth lecture, you go over the rest. And then this way, I feel like in about 3 to 4 lectures usually, the students would have, experience uh, both the views into this chapter. And if you want to be teaching this course, my advice is to always ask the student how do they feel about coding after the first lecture, and how do they feel about ML in the first lecture, and then ask them the same question again in the third lecture, and see the differences in responses. Usually, coding can be associated with not so happy moments. Let's remember it this way. However, it's actually a very good exercise. It's a valuable one too. Okay, perfect. So I think this is it for this chapter. Let me just run one more time. Yeah, we have everything set. So hopefully this was enjoyable. Uh, hopefully you enjoyed both approaches. Try both. It doesn't hurt if you try coding a little bit, every night. You can just maybe play with a few scripts. Because if you want to think about, if you work for your own firm or like your own company, you want to have algorithms that are your own, right? Whenever you use the platforms, there's going to be some cost associated with it, perhaps. You may not be able to tune everything the way that you want it. I mean, the models or the platform may not be large enough for your data sets. The data that you have, you may not be able to share it online with them, but to upload it somewhere else. So all of these things might imply you're going to have to code it, right? And at the end of the day, coding is actually free right now. It's downloading it, download it and play with it and save it and keep it. Negatives and positives all the time. Think about those. Well, I'm hoping this was interesting. Well, thank you all, and I'll see you in chapter 7. Take care.